Hey everyone, it's Justin, and in this video, we're going to be learning how to convert rates using everything we've learned already in this lesson, a skill which is called dimensional analysis. So before we jump into examples, let's define dimensional analysis. Dimensional analysis is just using a series of known conversion rates to manipulate units in a desired way. Basically, if you have a measurement in miles an hour, but you need it in feet per second, dimensional analysis is how you'd convert it. Actually, that's a really good example. Let's start with that. A runner runs at 10 miles an hour. How fast is her speed in feet per second? So we start off knowing her speed is 10 miles per 1 hour. And we know that we want to end up with the units being feet per second. So how can we get there? The key is all of those conversion rates that we know, such as 1 mile is 5,280 feet. So we can use that conversion rate to change the miles into feet. Notice that we put the miles in the denominator this time. The reason is because miles on top is going to cancel with miles on the bottom, leaving only the feet on top. So that takes care of turning miles into feet, but we also need to turn hours into seconds. We don't know a specific conversion rate for hours and seconds, but we do know how many minutes are in an hour and how many seconds are in a minute. So we use 1 hour over 60 minutes, and the hours on top cancel the hours on the bottom, leaving minutes on the bottom. Then we use 1 minute over 60 seconds, and the minutes on top cancel with the minutes on the bottom, leaving just seconds. So now we've replaced miles per hour with feet per second. And now all that's left is multiplying all those numbers together. On top, we multiply 10 times 5280 times 1 times 1, and we get 52,800 feet. On the bottom, we multiply 1 times 1 times 60 times 60, and we get 3,600 seconds. The only thing left to do is reread the problem. We don't want the runner's speed in feet per 3,600 seconds. We want her speed in feet per 1 second. So our answer needs to be a unit rate. So we just complete this division. 52,800 divided by 3,600, and we get 14.67 feet per second. Next problem. An Italian shopper needs to buy a large amount of an item that costs $5 per gram in the US. If $1 is worth 0.85 euros, how much does the item cost in euros per kilogram? So first we need a starting point, and we need to know where to end. Our starting point will be the price that we already know, which is $5 per gram. And our end, or what we want to answer, is the cost in euros per kilogram. First, we need to convert dollars into euros. The problem told us that a dollar is worth 0.85 euros. To cancel the dollars on top, we have to put dollars on the bottom. So here is our conversion. Now, the top of the fraction is in euros, so we can switch gears and start converting grams into kilograms. Since these are metric units, the conversion is going to be easy. Kilo means 1,000, so a kilogram is worth 1,000 grams. So then our conversion has to have grams on top, and there we go. So now we've got euros on top, kilograms on the bottom, and all that's left to do is multiply. On top, 5 times 0.85 times 1,000 is 4,250 euros. And on bottom, 1 times 1 times 1 is 1. The last thing we need to do is divide, but dividing by 1 doesn't change anything here, so the answer is 4,250 euros per kilogram. We could go on and on with dimensional analysis examples, but we should be fine with these ones for now. We'll come back to dimensional analysis and do more examples later on. Until then, try out the problems in our practice game.